All right, so what is it? Evening, right? Yeah, it's evening time. 6 o'clock. No, 7 o'clock now. So what's going on? My name's Tommy. Topics on Pwning, software-defined networking. I had to actually define the word Pwning to a marketing person today. It was actually really complicated. Anyways, don't care. Let's get started. Clickers, very useful. So usually in the talk, I talk about myself, something about SDN. I can walk, right? Yes? All right, good. Some component breakdowns of SDN itself and VR and the whole angles of what I try to do, what I found, and what maybe you could find in the future. Who knows, right? So about myself, so I'm a security researcher at Grim. Has anyone heard of Grim? Hand raise? No one? I'm really sad. No? Okay. Oh. Boom. Was it? No. Okay, anyways. All right, so first time presenting at BSides Las Vegas. Holy cow. Also BSides in general, so a lot of check marks and achievements, right? Being in Las Vegas as well. I mean, this is like day 2, I think, and I just got to the Strip, I think, or what this is called. No idea, but, I'm learning new things here in Vegas and being on the West Coast right now, kind of West Coast. If you're a West Coaster, this is my view of the West Coast, so I'm sorry. But, give me suggestions on what you think, I should do. I love suggestions, right? Background's always kind of useful, I guess. I started networking a long time ago in phone networks, so I had a job a long time ago wiring T1 lines. Does anyone know what T1 line is? Has anyone wired a T1 line? Has anyone liked doing that? Hell no, right? I think it was crap. But yeah, so I spent some time there, 6 months, didn't like that as much. So switch gears. Went to a different place, and they're like, oh, you're gonna be a net admin. Yes, cool, awesome. What kind of network? Oh, we can't tell you yet. Get there, they're like, oh, hi. It's a Novell shop. But 2010, by the way, and I'm like, what is this? You don't even learn this in school anymore, more or less. And if you do, there's something wrong there. But they had, an IPX, SPX set up. I don't understand this at that time. I was kind of like, all right, whatever, let's go with this. Research focus. So my background is, of course, in networking because networking presentation, always useful. I also do a little bit of machine learning, signal processing, target tracking, but we don't care about that kind of stuff. Networking. So fast forward, I like questions. If you have a question, just raise your hand, be an adult, right? Ask, I don't care. And the other thing is, I like to talk over drinks, right? Double whiskey sour is always good. That's my to-go. You can't really mess that up unless it's like a really bad dive bar concept, right? And if you don't drink, I like steak, so that's always delicious. So motivation here, SDN. So when I first started the SDN angle, I hated wiring. I had a lot of jobs where I wired something up, and then another contractor would accidentally cut 5 lines down the ceiling, and I had to rewire hundreds of lines because they made a mistake, right? So I got a lot of stories too in wiring and networking in general, but that's related things. But anyway, so nowadays computers getting super beefy, huge, not physically huge, well maybe physically huge, right? But resources-wise, you're getting the whole 512 gigs of memory, 1 terabyte gigs of memory, the huge 128 cores plus, depending on where you go, right? And the biggest thing is, you make these computers into some sort of hypervisor solution, plop some VMs in, support your infrastructure, and drop some buzzwords like SaaS and PaaS and whatever you want to call it, right? Check marks on the sys things, right? But the biggest thing here is, as your infrastructure grows and you have VMs here, you want to have the ability to customize and tailor your network to whatever you need, right? Either call your servers, fault tolerance, you name it. There's some sort of capabilities. And for those who don't know what a 25 pair wire is, this is one giant fat wire spanned out in a punch block. I hated this, and it's worse when you're colorblind. You can't match colors that well, right? No offense if you are, right? So SDN, software-defined networking. So I had a thing a long time ago where I tried to put a paper to a conference, right? And it was rejected because I didn't add the hyphen in SDN, and that was the only reason. And I'm like, are you kidding me, right? So if that offends you for a reason, I'm sorry. But so here's my primers, right? Lots of primers. So VMs, it's everywhere. VMware, VirtualBox, Parallels, you name it, we got something, right? And the biggest things, like I said before, is a VM has some limitations, right? You can't really apply quality service to some VMs. Maybe you can nowadays, depending on the hypervisor, but there's still a lot of different limitations in your hypervisor solution. Path selection, finding the best optimal path for routing, or you need sort of flow control. And customization, if you want to drop your own networking protocol because you're super fancy like that, then you can't really do that, right? In an off-the-shelf product, right? But the biggest thing is SDN. There are two major marketing terms: is of course global view and programmability. It's a lot of customization. So there are many vendors out there that do the whole SDN angle nowadays. Here's some lists like Cisco, HP, you name it, and there's of course software like Floodlight, Onos, and etc. Right? A lot of you Google something and boom, comes in the top 5-10 list, right? So in the whole SDN angle, there are things called planes, right? So I had someone look over the slides earlier and they thought an airplane, and I'm like, no, this is a networking thing, right? So there are 3 planes in networking: the application control and infrastructure. And we can kind of think of it as 3 separate networks here, kinda. Just go think about that. But each plane by itself has a purpose of business, administration, and your actual communication control for your clientele or your servers or whatever you call it. But 3 planes, 3 purposes. Remember that, not an airplane. So here's a lovely diagram I drew, right? Always nice blocks. Of course, it's always good. So what happens is in SDN there are 2 major components: the controllers and switches. You can add routers as well, but we'll just call switches for now, right? And each device is serviced in a plane. So controllers will be in a control plane. Your switches, computers, endpoints, servers, you name it, it's all in your infrastructure data plane. And what happens is, your business people love analytics, those nice fancy graphs with the spinny dials and trend marks. You get the idea, right? So they need some sort of an API function to query that kind of visualization, right? And you can put a threat map or projector screen for all your fancy people. So in the SDN there's switches, right? So I said switches before. And so my view for the whole switching angle, there's a lot of different switches out there, either off the shelf or online on GitHub. So OpenVSwitch, has anyone used OpenVSwitch before? Hand raised? 1, 2, kind of hand raised, 2.5 points, 275-ish, I don't know, depending. Yeah, so there's a lot of switching technologies out there, and I think OpenVSwitch, this is my view, right? So I can't be right. So this is, you take it as you learn, right? But I think OpenVSwitch is the most popular one because it's open source, because I love free things, because who doesn't? Versus going to Cisco, hi Cisco. Wait, does anyone work at Cisco? All right, good, very good. Not to bash anyone. But I don't want to go to some vendor product company and be hey, I want this switch. Oh, it costs $5,000 with a service contract support fee, and you can't do all this stuff, right? So I don't I hate all the rigidity nonsense. But so open source is always a good thing. Big community. I like making new friends, right? You can be all my friends later if you want to. Doesn't matter. Remember, drinks and steak. That's my thing. But yeah, so the biggest thing is OpenVSwitch is software, and it's plopped into a VM that runs some sort of NIX environment of your choice, right? And the biggest thing is it manages traffic. It's how your traffic in your network moves from A to B. So in the switch itself, they have flow tables, and that's how basically when traffic goes into the switch, it looks at this kind of a table scheme, and it's this traffic profile matches this line and entry in a flow table, and it's I'll go from port A to port B, and it goes to my destination. So here's an example of a flow table structure. So every time you have a network sequence or a flow or some sort of communication channel, whatever you call it on a network, a flow is inserted into this table, right? So everything that moves has a rule somewhere. If it doesn't have a rule, it can't move. So remember that. So this is an example rule where I had 2 boxes on a .10 network, and all I did was ping, right? So on one of the rules, the traffic goes into the switch looks over the table and is oh, okay, I got it from box 11, right? And it's a ping of some sort. So let's just shoot it out to 12 because 12 was the destination marker, and it says port 5 from port 5. You get the idea. It moves it virtually in virtual space. Software, right? So with the whole SDN angle, there are controllers. So controllers by itself, there's a lot of controllers out there. A lot of software. Everyone makes software nowadays. A lot on GitHub. You got Floodlight. Floodlight's the big thing that I'm going to talk about. But major competitor is RYU. Has anyone else used a different controller scheme? No. Any Cisco people? What is it? Contrail. No idea, but I will try to remember that. Or just talk to me later and I'll look it up. So there's a lot of things, right? So I talk about Floodlight because I was introduced to a much older software called Pox and Nox, but I moved along in the world and went to more fancier looking things, right? So Floodlight's there, and it follows a similar scheme of the whole application control and infrastructure. A lot of times when you buy a product from like a vendor, they'll start relabeling certain schemes, and they're like, oh, this is business market-y, fancy. So we'll rename the stack, or we'll rename something like this to make it our terms, and put some copyright trademark nonsense on it, right? But so like Floodlight's good because learning-wise, they do follow the scheme. They match the protocol to some standard, right? And when you do the analysis or investigating, you're like, oh, okay, so this is application control and infrastructure. So they do follow things. So this is important here. So capabilities, the controller is the brain of the operation. Like you have switches and routers in like a normal infrastructure, right? And they individually can, act by themselves. But the biggest thing is like, if this controller is like dead, you got no real network. I mean, you have switches that can kind of move, but over time, over a certain period of time, it doesn't know how to move traffic anymore because it doesn't have the decisive control of the controller. The controller's point of view, or the controller's function here is basically just to say, okay, I got some traffic, I have to figure out how to get from A to B, I do some math nonsense in the background, and then this is how it routes, and it goes. But when the controller is down, your packet goes into the switch. Switch is like, help me, I don't know what to do. Let's just blast it everywhere and hope it gets there. Broadcast, right? So the biggest thing is, like what happened to the whole like eggs in the basket, right? We try to avoid, security, some angles, risk analysis. I don't know. So like, if your infrastructure is solely dependent on a box or two and one of them goes down, all right, no bueno. So let's learn in Java. I get a lot of viewpoints that people don't like Java here and there, right? It's not really that bad, maybe. I don't know. Does anyone like Java? Boom, like this guy. I don't know, what's your name? Mike. That's his pseudo name. It could be really James. Don't know. But so in Java, it's not that bad, right? So it has the whole REST API function for your business people, but it also within the REST API you can manipulate and control your controller as like administrative nonsense. But the biggest thing is, hey, I got the service. It's a REST API interface. It's listening on every interface I have on this controller, and oh, by the way, there's no encryption or authentication to it. So as long as you find a controller in a network, if you're doing some scans, and it looks like one that has an API function to it, you can just send commands to it, and it magically accepts and listens to you. Whoops, right? So with that, so there's a lane in traffic called southbound traffic. So what happens is when the controller gives your instruction set to the switch, when it inserts flows and rules to it, it's called southbound traffic. It's kind of like a visual diagram, right? So what happens is that traffic by default is in plain text, and you can do some magic wizardry, replaying, whatever you want to call it, and your switches on the other side will kind of like say, okay, sounds good, I'll take that. Any questions so far, by the way? I love questions. You have questions, just raise your hand, right? So the OpenFlow protocol and fuzzing. So I would say I'm a network person by trade, I guess. Depends on the angle, but SDNs, I've been doing SDN for like, I don't know, probably like 5 years now, I think. I have no idea. A long time, right? but it's kind of like relatively new nowadays in the market. So we'll just go with it. So in the your first packet in networking, right? Your client sends the traffic to the network. It does this whole ARP thing, right? Adds this resolution protocol. What does a network seal make for a noise? Network seal. Think. Protocol. What is this protocol? This guy. ARP. This guy, right? ARP. It's really corny, but the funny thing is, like, I think like 6 years ago or 7 years ago, I actually got someone's phone number with that corny joke. So that didn't end well at the end, of course, but it's still a good achievement for me, I think, to say this kind of a quirky, like, nerd joke that actually worked. Anyways, don't care. So, in the whole angle, SDN's a little bit different in the sense that when you communicate on your network from computer A to computer B, it takes the very first packet in your network flow, your stream of traffic, right? And what happens is that initial packet is sent to the controller, and the controller is like, okay, I'll look at this packet, and let me try to find the profile of the packet and determine what does computer A need to go to? How does it need to route? What's the purpose of it? That's the idea based on the first packet. And so what happens is that initial packet is encapsulated into an OpenFlow message, right? This guy seems kind of confused. What's up?
I'm just thinking, what happens when you port scan through an OpenVSwitch? You just get a load of traffic going to the controller.
Boom. So we'll get to that. Okay. So the guy was thinking about port scanning. We'll get to that kind of interesting thing later. But good visual eye contact thing. Anyways, so first packet goes to the controller. Controller looks at it and is like, okay, I know where this goes. And he goes, boom. So the flow gets inserted into a switch. Switch is like, oh, cool. I can then forward all the other like 900 bajillion packets through the rest of the network. And we basically have a happy network at the end in the sense that both clients at the endpoints are communicating. But what happens is, so the other thing with SDN is everything is virtualized. We don't have an actual visual map of a network because everything's software driven. So one thing with SDN by itself is it uses two techniques to identify links in a network, right? Because we don't have cables anymore. Everything is just bits flying. So it uses two discovery protocols to identify links, and all it does is layer 2 broadcasts everywhere, spams all your switches, all your ports, and it gets really noisy. So any like Cisco discovery protocols or Juniper discovery protocols, people, same idea, just different marketing term and label stamp. You get the idea. But the biggest goal is with their discovery protocol is it finds the shape of your like network graph. You want to call it graphs, right? Math people, graph. And it determines the best path based on latency. So what happens is when the discovery protocols are broadcasting in a network, that time it takes to measure between switches is your measurement of latency. And then the controller is like, okay, to get from switch A to switch B, it took me like 5 milliseconds. That is my latency for the link. So that when it does calculations to determine the best path, it starts adding numbers together and it's like, oh, to get from from one point position of the network to the other, it does some crazy math, and it's like, this is the best path. Kind of like when you're driving a car and you use Google Maps, and Google Maps kind of screams at you, it's like, oh no, take a right turn down this like sketchy alleyway and hope you don't get shot, right? But what happens is Google Maps in the background does some calculations to determine, how do you meet your goal of getting to the destination fastest, right? And without having traffic or congestion. So there's some like weird things in SDN. So what happens is in the southbound communication, right? So like I said, first packet goes to the controller, rule comes down, right? What happens is the flow rule, so when the controller inserts this rule into the controller, so to speak, right? There are timers there as well to maintain, say, okay, after a certain amount of time, we'll keep this rule into the switch so that all the remaining traffic goes through. But then once an expiration timer comes out or an idle timer comes out, that flow rule will like disappear. So somewhere midstream in your traffic, one random packet will shoot back up to the controller to get reanalyzed to say, okay, this is the path again. But what happens is sometimes, depending on how your network's configured, your traffic may midstream be rerouted in a different path depending on how it's constructed, because everything's software driven, right? You can't really, you could do that in like real networking, but there's a lot more like issues like telecom issues, right? So random things I found interesting. So this is about Vuln research. So random things I found interesting using Scapy. So this guy, what's your name again? Richard. So that's his pseudonym, Richard. It could be like Bob or something. I don't know. Anyways, I'm saying everyone's pseudonym because I have no idea, right? But so port scanning, you can SYN scan all day, of course, and you can even change like even like SYN flooding, DNS, denial service. You just change like your source address field or destination address field, right? So the interesting thing about SYN flooding and all the other things is like each packet fills a role in the table. So your table, so basically, if you just change an address field or you just change a little bit something like that, each packet will fill the table, so your table becomes huge on the switch. So like when the switch starts reading this table, it gets slower and slower and slower and slower because now my like 10 rules in this table becomes like 1,000,000, and switch is not happy, and all your customers, so to speak, aren't happy. So I mean, it's kind of it's not lame, but it's a mentionable thing because I thought it was kind of like a interesting setup. So the other thing too I found was kind of interesting was that, so with the whole like first packet going to the controller as like the way the profile networks stream, right? If you send a super large packet, like a huge like max out all the fields possible packet concept, it actually like starts syncing your CPU on the controller down by like 10%. I use this kind of like a machine, so like you can do some ratio calculation to determine the rest. But I mean, I think that it looks pretty beefy, but like all the cores went down to like 10% lower, just because I sent one large packet. So that's kind of like that's a little different, right? But the other thing was like because flow rules they do expire over time, like I said, and the default is like 5 seconds. So like if you just write like a really slow loop, like while true, sleep 5, send packet, sleep 5. You repeat this cycle, so to speak. You could kind of like start slowing down the controller there. And if you have like 5 clients, or you have one client and change the source or address field, or source or destination address field, you can kind of like start really throttling down the controller just because you follow the de facto standard. It's just you use it in a much interesting way. So northbound REST API. So that's the other like angle and the whole controller angle. So it's web stuff, right? So you can use curl all day. So I tried to fuzz the API interface, and Java was really upset with me. And so it was kind of like trying to process my request. And what happened was it literally just locked up in general. So a lot of times it's like why is this happening? And people just say it's Java, right? But I don't know. This guy likes Java, right? Mike, boom. Mike likes Java, but I don't care. It's just like public static void main string args blah, right? But anyways, so it would periodically lock up. The network didn't do so well because controller wasn't really functioning well, and switches can't get instructions. So it's like, what to do, right? So it got even worse because I had to throttle down the fuzz to the point where like it was like 200. Gotcha, man. 200 like requests a second the most. It was like that was the fastest I could get, but it's still unauthenticated. So like you just send a command and it accepts, right? So someone needs to put a password there. That's kind of useful, right? The Discovery protocol. What happens is yes.
I was just going to ask a question though. How were you able to get to that perspective in the previous slide? Be able to hit the API. Were you on something that had the same visibility to the switches, or were you encapsulated?
Boom. A good question. So what happens is when you are a client in SDN, you're in that whole infrastructure data plane, right? What happens is the REST API resides in the northbound or the application plane. So you have to reside in that particular network interface. But what happens is in the virtual scheme, your VM still has an interface that listens to some sort of internet access network or another internal network, right? But in the SDN angle, you virtualize an entire network within the VM or within some set of VMs. You need to reside in a similar level of like networking. But going from like your infrastructure data plane, it's not really that easy. But so I have 2 minutes to cover that guide, so I'm just going to speed this up a bit. So path selection discovery protocol, if you spam that thing, you can basically force a network to redraw the pathing by itself. So it's like you don't need to really man the middle of anything. You can just force the network to say, hey, move everything there, because what happens is because it uses the discovery protocols to measure latency and inform the controller starts seeing these packets, but they have like weird timestamps, right? It's going to measure them like, oh, this link took me an hour to go through, so let's just go everything in another direction. So it's like a really weird way to like move things in the whole networking scheme without doing any sort of rules. Anyway, so hiccups that happen. So when you try to I try to mirror port traffic from one box to another. I had a switch in between, but when I tried mirroring it, layer 2 dropped everything on the switch because it didn't match into the fields. So my solution here was this really janky way that kind of worked. Right? TCP dump piped to a netcat tunnel that piped into a replay thing. This guy's like, what the hell are you doing? But it works. It's just not really practical. I mean, it is practical, I guess, with this angle. So it kind of worked. Summary, SCPI, stop now. Boom. Summary, I am done. No questions, hit me up on Twitter. There's my Twitter. Here's a QR code you can scan if you want to. It's legit. Don't worry about that. Follow Grim. Always good, right? That's where I work. Thank you.